you have to practice it. Now, by way of introduction, I'll explain it this way. I was thinking about it this way. And in my house, I'm famous for coffee in the microwave. I'm grading and I heat up my coffee, I put it in the microwave, and being old, I put it on for 30 seconds and I forget why I'm standing there. And then or I get doing something else and I forget it was in the microwave, yeah? So about 4 days out of 7, I have a coffee cup in the microwave that's cold coffee. That's easy to do for an old person because, you kind of get lost in the details and you get distracted. Because of that, you are actually going to be much better at today's lesson than I am because you're going to have this big thing and it's easy to get lost and go down a rabbit hole and forget where you were, but you're so smart and young that would never happen to you. So you're going to be super successful and it'll be more like you'll have to help me with this kind of question. So it goes like this. Number 8 is this. Y equals e to the x times x squared plus 4 to the 50th. The idea of the day is a combination of lessons, or a combination of techniques. So you might have power rule with chain rule, or quotient rule with power rule, or power rule, chain rule, and quotient rule on the same power. It's important that you don't, in doing the chain rule, get lost in the fact that you forget you're doing overall the big problem is the product rule. So let's go here. The idea is what's the derivative, by the way? That's kind of important. What's the question? Is the big picture here a product rule and the chain rule's inside, or is the big picture chain rule and the product's inside? Okay, I heard a little of both. And the answer is the big idea is it's a product. It's one big thing multiplied by another big thing. But when I go to take the derivative of that guy, that'll require the chain. Do you agree?
Yeah. Yes.
Okay. So then, would you give it a go, please? Remembering that the big picture is you're doing a product rule, and within it you'll see a little chain rule. Oh, hi. How are you? There's a couple here. I don't know if there's a notice. There's no notice. Okay. Don't simplify it. What? Bro, how many boosters? 5, 10, 22. Okay. Here we go. Sorry, I am behind. Once again, I forgot what I was doing. So I'm feeling something like product rule. First stays the same. E to the x. Derivative of the second. The derivative of the second is what? 50 times the quantity. X squared plus 4 to the times. Excellent chain rule. Well done. Plus, second stays the same. X squared plus 4 to the 50th times derivative of the first. E to the x. Okay, now you can see that you could do a lot of algebra to that. You could take out a lot of greatest common factor action. Right? E to the x is there. X squared plus 4 to the 49th. I don't care that you do that, although if you want to verify your answer is correct, in the back of the book they might do a little algebra on it. I don't require that. You will sometimes, to choose your multiple choice answer, have to do a little of that algebra. We'll practice that. For now, you may leave it. You with me?
Yes.
All right. Number 9 is similar in that you're combining ideas. It is G of T is this. Hi, what? Oh, hi. Hi, Carver. How are you? Good. Sine of, oops, that's 2t. She messed me up. Way to go, Carver. Sine of 2t over cosine squared t. What combination of rules will this require? Quotient and chain. Yeah, you actually have two chains. Both of those derivatives will involve a chain. So give it a go. See how it goes. Actually, I take it back. Fundamental rule of math is, can you make your life easy up front? Is there, I don't know how well you know your identities. Do you know your identities pretty well?
No.
Okay. Well, if you don't know your identities, then I guess you're set for chain rule time. But if you do know your identities, you might know that this sine of 2t is equivalent to 2 sine of t cosine of t over cosine squared. So this, if you really wanted to make your life easy, instead of all this quotient chain stuff, you do that, because that just means take the derivative of 2 tangent t. Isn't that a heck of a lot easier? G prime of t is. Now that then is going with the assumption that you know tangents derivative. Do you? Okay. If you don't know that, then that also is not helpful. But if you do, then you say, woo, that was easy. Again, math is easier if you make your life easy first. Let me have you do, that's actually all the new ones. That was easy.
Yeah, but isn't it two?
Did I do, oh, yeah, there's a 2 there. Sorry. Yes. Thank you. You're absolutely correct. I screwed it. Okay, are you with me?
Did you do quotient rule first? Yeah, I was so
That would have been quotient rule, and when you did the little derivative pieces, that would have required the chain. Okay? All right. Just to see how you're doing on recent ideas, would you go to box 3 for me? Is this about what you have in box 3? Yes. Okay. Would you do part A, which is to say critical numbers? I know the book's not open, but part A says find the critical numbers. Okay, so find the critical numbers. Then part B, I want to change it to find where the relative max and min values of f occur. Use the first derivative test to justify? Why would I want you to do that? You've been doing that forever. Maybe we should do the second derivative test to justify. What do you think? First derivative, oh, justify using the first derivative, justify extreme. This, I don't know what I'm doing here. I'll just do it what it says. Use the first derivative test to justify the extreme. Okay? I don't know why you're doing that. I assume you can multitask. While you're doing that, I want to make sure you read that carefully and understand when it says find where the relative max and min occur, that only implies that you really need to find the x. If it says where did the max and min occur, find x. If it says what is the min, or what is the max, that's a y value. Does this factor, I hope?
No.
It does not?
No.
It doesn't factor because you stink at factoring, or you don't think it really doesn't
No,
factor?
it really doesn't.
Yeah, that's unfortunate.
Yeah, that's interesting. So let's just leave the answer for that.
Wait. You're saying that if you get a quadratic that doesn't factor, you're screwed. You can't solve it?
Who's this?
Should I go to Mrs. Lamont's room and get an answer for one kid over here? That knows the quadratic formula? Do I need? I think you know the quadratic formula.
That was algebra.
Yes, algebra. You learned it at the end of Algebra 1 book, and nobody understood it, but you didn't learn at the start of the Algebra 2 book, and then you understood it. But yes, I do expect you to use the quadratic formula. You bunch of Marys, go. I'm grateful for the practice. I was getting a little rusty. Now I'll be all good. Wow. This isn't as much fun as I thought it would be. Now we'll use a little number sense. Oh no, we don't need numbers. What? Did I make a mistake?
How is it?
I'm just making sure you understood it was 32. 33. Just verifying. Good job. Understanding. Okay, so in terms of placing these on the old number line, no, you may not use a calculator. What is root 33 about? Between 5 and 6, okay, so let's say closer to 6. So 6/8 is 3/4. What's 1/8 plus 3/4? Positive or negative? Come on, 1/8 plus 3/4. Positive or negative? Positive, okay. So that means 1/8 plus root 33/8 would be right of the origin. What about 1/8 minus 3/4? Negative. So the other root would be this side. Okay, are you with me?
Yeah.
All right, now, again, all good techniques here. I could do a sign test on the first derivative. Don't you agree that's what the first derivative test does? A sign test the integers, yeah? A little bit of a shortcut or something you could also employ is we know the derivative is a negative cube. So if I kind of laid this negative cube shape on top of the old axis, wouldn't it go like this? Right? So wouldn't that be better than sign testing? I could say, well, feels like the derivative would be positive, negative, yeah? All right, now that would be enough to say y has a blank. The derivative went positive to negative at 1/8 minus root 33 over 8. So is that a max or a min? A max. Does that jive with negative x to the 4th-ish? That we would first get a max. Yeah, okay. Then the derivative is going negative to positive. And that feels like a min and a max. So let's go, y has maximums. It has two relative maximums. At where? X equal 1/8 positive and negative root 33/8, yeah? Why? Y prime changes positive to negative. Y has a relative min at x equals 0, poor k. Y prime changes negative 2. Positive. Boom. Negative. You with me?
Yes.
Okay. Now let's go to number 4, which is something I don't have here. But number 4 is the same question, which I guess is A and B. What did A and B say here? A and B. So A and B is find where that curve has, that same curve, has inflection points, and I'll throw you a bone and say just, actually maybe it's not 2, yeah, I'll just say the x only, not the y, and where the curve is concave up and concave down. Go. What is inflection and concave up and down all about? What determines it? Second derivative, yes. There, some homework for you. Especially if I easier way. No, just take these out. You should have one of these. Although one might be You don't have to reinvent the wheel, by the way. You can start from the first derivative you already did. 48 times 3, you probably must have a calculator for, because, yeah, because to multiply a 2-digit number times a 1-digit number is way too hard, right? Sorry. It should be more positive. 48 times 3, we could do that mentally. 40 times 3 is 120, plus 8 times 3, 24, so 44. Oh man. Is this factor? 24. Let's take out a negative 24. What do you say? What do you say? 6x third. I'm feeling like it's factorable. Wait. 3 and 2 maybe on that 6. And difference of signs. Yeah. It's good. It's good. Okay. So, what are the zeros of the second derivative? Negative 1/3 and 1/2. Now I'm sign testing the second derivative, y double. I could do a sign test, but I could also think about the shape of negative x squared. Wouldn't it go negative, like a negative parabola? The negative, positive, negative, yeah. Okay, so that should be good. Let's do the inflection point conclusion. Y has inflection points at? And inflection points are where the graph changes concavity, right? But we justify it with the sign of the second derivative. So the wording should be like this. Y has an inflection point at x equal negative 1/3 and 1/2 because y double equals 0, changes sign. Because y double changes sign. It's not enough to equal 0. It has to change sign. All right? Where's the graph, the original graph, concave up? CU. Concave up, that's an interval, not a point. So it's concave up on negative 1/3 and 1/2 because y double is positive. Okay, concave down is very much the same way, but it's two intervals from negative infinity up to negative 1/3 or 1/2 to positive infinity, but this time because y double is negative. All right. Last but not least, the last use of the second derivative is to actually test for extrema. It tells us concavity, it tells us about the shape of the graph, but we could also use it to find mins and maxes. Now here's the bummer of this that I guess I didn't think about. I don't really want to put that critical number into that quadratic. You with me? Because that would be terrible. But the good news is I kind of already know what's going to happen. So let's just do 1, okay? Wouldn't you agree that this leftmost one was positive 1/8 minus root 33/8? Yes? Now we said that was a max. So how should the second derivative test roll for that if it's a max? Now we should be saying something like y has a max at x equal 1/8 plus root 33/8, how does the second derivative test conclusion go? Because, talk to me. Because what? I feel so wrong. Mr. Phone, what are the two pieces to the second derivative test? Anybody? Can you give me one piece? Can you just make me cry? It's a combination of the curve going flat and the graph is concave down. All right. So how do you justify that you say that it's flat? Because y prime is 0, and how do you justify that it's concave down? Y double is negative. No, I didn't actually sign test it. I'm just kind of assuming that's the case. Are you with me? All right. Last but not least, would you go to box 25? Give me as many of the other 5 trig derivatives I haven't given you that you can remember. You can remember all 5, super duper. I gave you the first one. Kylie? Kylie, what's the derivative of cosine?
Negative sign.
Well done. Tegan, do you know the derivative of tangent? Ooh, you're a champ. Okay. Jasper, do you know the derivative of cotangent? No? Thank you for your honesty. Lindsay, do you know the derivative of cotangent?
Negative cosecant squared.
Negative cosecant squared. The derivative of secant. Ms. Witherspoon, what do you say? Secant tangent, correct them all.
Straight.
Yeah.
Derivative of cos times negative sine.
Not negative cosecant?
No.
Are you sure? Wow. Rough day. Thanks. Where did I? Oh, yes. Okay. Thank you. I'm really tired. Secant tangent. What is that? Okay. What's the derivative of cosecant? Miss Riley, what do you got? Derivative of cosecant? Yes or no?
Negative.
You're a good start. Cosecant? Cotangent. All right, cool. Go to box 21. 21, we're just cranking out problems right and left, right, Haley?
Right.
Right on. 21, go to box 21. I give you this limit statement. It's meant to be a rectangle problem. I'm just not using summation notation. But it is a sum in there, you can see. This first one over n does represent the base, or the delta x, which would eventually become dx in an integral. And these are the heights. So it is like a summation. Could you write it in summation notation for me, please? The limit as n goes to infinity does not change. But the limit of what? What's in there? First of all, that 1 over n is unchanged, right? Then what else? I over n. Well done. And what's the Wouldn't you agree that the counter, that which is changing, are these guys, yeah?
Yes.
So what's the first I value? 1. What's the last I value? Okay, if this is 1, then it must be something over n. N, right? The last one must have been n over n to equal 1. Okay, cool. Summation, check. As a definite integral, what is this as a definite integral? What's the region beginning value? Not 1. Try again. 0. What's the width of the region? 1. What's the function? X. Is that enough? Not enough. That's bad calculus. You cannot find the rectangle area with a height. You must have a height and a yes. Okay. If you were to integrate that, what's the antiderivative of x, Colin? That's a softie, my friend. What's the antiderivative of x? X squared over 2, indeed. From 0 to 1. When do I evaluate? Ms. Hess, do I put in 1 first or 0? 1. And then 0. So this would be 1/2 of 1 squared minus 1/2 of 0 squared. So the area is 1/2. How else could I have done that problem with geometry? Imagine the graph. It is y equals x from 0 to 1, yeah? What is that area? Yeah, that's right. Okay, so 1 times 1 divided by 2. That makes sense. Okay. All right. Let's do one more. Let's just really run it in for the touchdown, shall we? Number 1, a particle moves along a circular path described by the circular equation x squared plus y squared equals 9. Find the rate at which the x-coordinate is changing at the instant the particle passes through the point 2, 2, 1. Given the y-coordinate is decreasing at a rate of 2 meters per second at that instant. Would you please start by writing the givens and identifying what is being asked, and then differentiate with respect to the point. Not really getting much. How we doing? Okay. You got any what?
It's negative. It's decreasing.
Oh, you are good, lady. You are good. You're on your game today. What is the derivative of the equation with respect to time? Mac, what's the derivative of x squared with respect to time, my friend? Can you do it now or no? You can think on the spot. What's the derivative of x squared with respect to time? 2x. 2. Derivative of y squared with respect to time. Micah, can you do the derivative of y squared with respect to time? Say again? Wonderful. 2y dy dt. Sorry, my ears are terrible. All right, do we agree with the derivative with respect to time? Can't tell you how many people forgot that the derivative on the right-hand side is 0, not 9. A lot of people kept it 9 on the test or something like that. It zeroes out. D, you're given a lot of stuff. The x is 2. The dx dt is that which we are looking for. Y is 1, and dy dt is negative 2. All that equals 0, so dx dt I feel like would be negative 4 over 4 root 2, or negative 1 over root 2 units per second. Okay, that's done. Now, would you like some good news? How about some good news?
Yeah.
All right. That homework is actually Monday's homework. I feel like I'm just... So we're going to take... This is Monday. All right, we're doing Monday. So we don't have any homework over the weekend. That said, let's go over the fun sheet that's due today, and then we'll walk out of here all happy, yeah? There you go. We should have a little fireball dance party, huh?
Yeah.
When I get that song in my head, that's sticking everybody. Oh yeah, DJ's really good. Everybody in center music person's great during the volleyball game. We got great music. Way better than volleyball. No, it's good. So you guys got smoking. All right. So anyway, for this, let's just. I'm feeling tired, so I feel like you should do the work. What do you think, Tegan? You will inherit the earth someday. Okay. Ms. Cohen, or Mr. Cohen, sorry. Mr. Cohen, for this, if the derivative, second derivative is greater than 0, which graph matches that?
B.
B. Okay, that implies that the curve is concave up, and that is B. Esther, for the second one, F derivative negative, what does that imply about the graph? Concave, did you say up or down? Down, I'm sorry, and which graph did you say is that? C, thank you. Larissa, if the second derivative goes positive to negative, then what's the graph doing? Okay. This one's going concave up to concave down, has an inflection point, and that is graph A, as the lady said. And F double goes negative to positive. Chance, what is the graph doing, and which letter did you choose? Okay, increasing, decreasing, did you say increasing, decreasing, or the slopes are decreasing? Slopes are decreasing, decreasing, I see what you're saying. Concave and concave down to up, and that is D. Beautiful. All right. Here we go. Some common econ / business statements. The outlook is great. The growth rate keeps increasing. If the growth rate is slopes and the slopes are increasing, that implies the slopes are increasing. And so that, I hope you ask for A, that is 2. Okay? We're losing money, so we're decreasing, but not as quickly as before. So we're really losing money, but not quite as quick. So you said that is 4. Good. Okay, we're losing money, so sloping down, and it's getting worse. So we're losing money, now we're really losing money. That is 1. We're doing well, but our growth rate is leveling off. So doing well implies we're growing. But the growth rate is leveling off, so it's growing, but the growth rate is flattening out. So that is 3. Okay, business had been cooling off, so it feels like it was increasing, but at a less and less rate. But now it's picking up. So that is 6. Business had been picking up better and better, but now it's cooling off. And that is You guys did those well. I thought those would be hard, but you guys are smart. Okay. If I look at this as the F graph, then a point of inflection is where the graph changes. No, good try. A point of inflection would be where the F graph changes concavity. Okay, so where does it change concavity?
C.
I'm feeling it's hard. It's a tough call, but I'm feeling that was C. If you felt D, maybe, but you would be wrong. It's C. Okay. Intervals where F is increasing. F is increasing. Well, this is the easiest case. This is F. F is increasing there from 0 to B. And where else is F increasing? E to G. Right? Do we agree? Okay. That's just reading the graph. That's very rarely that soft, but this one they gave it soft. Concave down. Concave down on what interval? 0 to
C.
B?
B. C.
C. Okay. Okay. By the way, common criteria for concave up and down is if you draw a secant line between points on the curve and the secant line falls below the curve, that's concave down. If the secant line falls above the curve, it's concave up. All right, label this graph. Now we're thinking of this graph as F prime. I kind of wish I would have separated these throughout the worksheet so they weren't all butt against to each other, but what are you going to do? All right, point of inflection now. Still say F double changes sign, yeah? But now as far as where do we go for F double, that's a different thought process. F double is the slope of F prime. So I need to know where the slope of F prime changes sign. And that is at
B.
B and E,
B.
right? Okay. Intervals where F is increasing. Again, every time I started with the big idea of calculus. Increasing if F prime is positive. Where is this is F prime's graph, so F prime is positive on A to D and F to infinity or F to G, depending on how you look at it. I'll take it. You with me? You really should just say G because you don't know what it does after G. Intervals where F is concave down. Now, concave down is where F double is negative. And how do I extract F double from F prime graph? F double represents the F prime slope. Okay, so F double is negative where F prime slope is negative. Here's the F prime's graph. The slope is negative or the function's decreasing on B to E. And that's an interval. Once you get at these are fun and not much work. Okay, F double. Now I'm thinking this is F double. A point of inflection. Again, big idea is where F double changes sign, yeah? So now I'm just looking for where does this graph change sign, and that's at A, X equals A, D, and F. Okay? Intervals where F is concave down. Concave down is F double negative. In this case, now this is the graph of F double, so I just see where it's negative, which is 0 to A and B to F. Yeah? Don't disregard that first little interval. It needs to be counted. Okay? All right. This one's kind of funky. Neil sells solar-powered phone chargers over a website. In a report to investors, she stated reached a point of inflection when I started using pay-per-click advertising, whatever that means. In what month did that occur? So, what did you say? Anybody? Give it a go. Take a guess.
3.
3. Yes. Excellent job. So inflection, let's start with the big idea. Do you agree of a point of inflection is where the second derivative changes sign? And the second derivative is the change in the first derivative, right? All right, now I don't really have the first derivative here, but the derivative really goes to how it's changed, yeah? So I could start by saying, well, I can't take the derivative because I don't have an equation. I can't find the change at an instant because I don't have an equation. The best I can do is say, I can look at the change over an interval and say that's an approximation of the derivative. So I'm going to use the change in sales over change in month as an approximation for the rate of change on sales, yeah? Now in this month, sales went up 30 in 1 month. In this case, it went up 20 in 1 month, up 10 in 1 month. Now it's going up 30 in 1 month, and up 60 in 1 month, and up 80 in 1 month, and up 110 in 1 month. Now that's like the second derivative. Those are the changes, the derivative, excuse me. That's like the derivative, that's the change, right? Second derivative is when the change in the first derivative changes. Now, what do you notice about these guys? The first derivative seems to be decreasing, which would imply that S double is, if S prime is decreasing, then its derivative, which is S double, is negative, yeah? But after that, the derivatives, or these changes, are increasing, which would imply that its derivative, S double, is positive. Now, visually, if you're a visual person, you would say it was going up 30, up 20, up 10. So the slopes were kind of getting smaller, but then they went way big and bigger and bigger, so it did that kind of thing. Isn't that a point of inflection? Yeah? So I said point of inflection at, I said between 3 and 4. You could say 3 is fine. That's my conclusion. You with me? Okay. All right. For 7, the first one. Mr. Raring, that first one. What's the sign of the first and the second derivative for this graph? Okay? And F double? Negative. All right. I remind you the first derivative is all about increasing or decreasing. Is correct because that's decreasing. The first derivative is negative, and concavity is the second derivative. So negative, negative, I agree. Second graph. Karis, first and second derivative signs, please. Thank you. It's increasing, concave up. So positive, positive. Who haven't I spoke to? Teddy, this third graph. Signs of first and second derivative. F prime is positive and F double is negative. Increasing, concave down. Miss Gardner, the last one. F prime negative because it's decreasing, and F double is positive because it's concave up. Okay, Miss Miller, how you doing, Charlotte? Good. Does this graph seem to indicate, or this table rather, seem to indicate that F prime is positive or negative?
Positive.
Why do you say that?
Because the values are exciting.
Yeah. F is increasing, or at least the table seems to indicate. I have no idea what's going on between, but it seems to indicate that F is increasing. So I agree that F prime seems to be positive. Again, seems to be. I have no idea if that's for sure. What about the second derivative? That's a little harder. That's the change in the change. So what's the first change? 3, and the next change? 1. Are the changes increasing or decreasing? The changes are decreasing, so F prime is decreasing, it seems like. If F prime is decreasing, then F double, Miss Howry? Negative. F double is negative because the changes are decreasing. Something along those lines. You with me? F double is the change in the change. Okay. This to me is one of the hardest. F double is, or F prime is negative. That implies that F is decreasing. So if the last y value, that seems to be true here, it did decrease there. If the last y value is 5, then the next y value should be less than 5. Therefore, you should have a 5 there, right? The harder one is the other one. If F double is positive, then the changes are increasing, all right? F double is the change in the first derivative. So the changes are increasing. Now this change was negative 3. So the next change should be greater than negative 3. Give me a number that's greater than negative 3. Negative 2, for example. If the next change was greater than like negative 2, then where would that put it? 3. All right. So if we go right up to the limit, like the next change was negative 3, what would the next value be? If the next change was negative 3, the next value would be 2. But the next change is actually greater than negative 3, so it'll be a little more than 2. So F3 would be between 2 and 5. You follow?
Yes.
Okay. This guy, I wish I would have started my calculator up. Do you need just the answers to this, or should we talk through this?
Talk through it.
Okay, sounds good. All right, so if you got your calculator and put the function in y1, please. Oh, violation of your privacy. Do. Maybe we can get through this one before the bell rings. This one's one of those ones that would be on the test and requires you to make connections. Pretty common AP style question. Okay. So, did you put that function in yet? 5 sine x, no. X to the 3 Okay, like that, yeah? I would next set my window to 0 to 5. The calculator, just so you're clear, the calculator doesn't know actually how to take a derivative of that. When the calculator does the derivative for you, it is making numerical calculations of slopes between 10,000ths of a point apart. Okay, it doesn't know how to take the derivative. It's making actual numerical calculations, thousands of them, to make the graph of the derivative. It will take a while if you don't give it a break and shorten your window. So I would change your window to 0 to 5 because that's what they tell you in the problem that you're between, okay? Now, to have the calculator graph the derivative, this is what I try to give you instructions on, whether it's successful or not. You want it to take the derivative of F1. The derivative button, the best place in this is to go right here next to the 9, this sub-menu button. A lot of good stuff here. Summation, we talked about it earlier. Here's the derivative button right there. Take that, and we want the derivative with respect to x of the function.
Good morning, ethics gamers. Please rise to the pledge of allegiance.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
National Beer Army Society will be like Dairy Queen Blizzard. Ain't the name I'll be having to it. Like I'm starting a weekend with a blizzard. We all fast food free. All boys interested in strike out the boys basketball team. And they name it Slaughter. There's some of our tonight. If you can't make it today, be sure to consider Slaughter's for information.
So should I find where this red graph has zeros?
Costa
Or
Rica.
has extreme.
If anyone is interested in a trip,
Extreme,
please
okay.
contact Mr.
Where
King.
the derivative changes sign, slope sign, the second derivative would change sign. So the thought process is like this.
One class at a time. If you're interested, stop by counseling for a
F double equals slope.
That's great. All animals do the freaking second class. Ooh! Before that happens, please check your closet for outerwear that you will no longer use and donate to Latin Club's Coach for Colorado Drive. Collection points are each collection since 11/9. Your donated items will be cleaned and distributed to CD Colorado residents, help keep them warm and healthy. Thank you for your generosity. Thank you, Sam. Devil's Drama Department presents a musical murder/mystery, Curtains. It's the opening night of a musical, and the leading lady has been poisoned for the quarantine cat.
Okay, now it says inflection point, so I want the X and the Y, but be careful. The X is what you want, not that Y. That's the derivative value of that X. You want the original function value of that X. So I would store that.
Senior high students. Seniors, are you aware of the application deadlines for colleges and universities where you're applying? November 1st is right around the corner.
And then to find the Y, you do F1 at that value.
Also for seniors, would you like to earn some money to help pay for college?
So the first solution should be
7th hour for a scholarship workshop geared towards navigating the endless opportunities scholarships out there. Thanks for helping those seniors, Evan. All ninth graders that have not attended the admissions game will be required to do so on Tuesday, October 30th, including last name Hobbs through Lotus and summer
That's your
through
first
D.
inflection point. Okay.
Junior high,
The X is the extrema of the first derivative, but the Y is that X value in the original function.
for the AMT8 math competition and have a little fun. 7th and 8th graders can still sign up for the math competition. The space is limited. Stevens Brewer and Miss Kent sign up. 7th graders will be required to attend the 7th hour meeting with Mr. Northland auditorium beginning on Monday, October 29th through Thursday, November 1st, based on last name.
Oh.
Please plan accordingly. Dazzling Jacks. Come up tonight to Trailblazer Stadium at 7 p.m. to honor our senior football players and watch the Jacks devour the Eagles. The theme is a blackout. Make sure to win your
right?
DHS cheer team to up to travel south to compete in the Midwestern 4A cheerleading regional.
Hey, talked about South.
We'll compete against rival high schools such as Green Mountain, Boo! And everybody, go Jacks! And also, good luck to the marching band as they head to Pueblo for the state competition on Monday. Go Jacks!
Are you out there? Have a jaggery day.
Who is that kid?
Two.
That the energetic one? Sam. I don't know him. Oh, I love that kid. Hilarious. Okay. All right, 4.659. Again, you have to find the original curve at that point, so you should probably store it.
Yeah, Haley, you also need to give you.
Store it. Then.
Oh, I have the shirt.
Shucks. We'll finish going over Monday. If you want to turn it in, you can. Have a good day. Thanks.